Good morning, everybody. It's a pleasure for me to be here today. My name is Eloisa Schmidt. I'm the Corporate Sustainability Manager with Bechtel. And I'm really excited to introduce Research Team 411, leading the charge in decarbonizing capital projects. Before I get started, I want to introduce the group here with me, my esteemed colleagues. We've got to my left, Jim Alloway with LyondellBasell, Hassan Helmi with Autodesk. We've got Cheryl Boning with Fluor, and Ed King with ExxonMobil Corporation. So let's talk about greenhouse gas emissions. Many of the companies here have set ambitious goals towards greenhouse gas emissions, but not all. While setting ambitious goals is the first step, there are a lot of challenges in getting from point A to point B. Not all technologies that are available today are implementable, but some are. So, what are we here to talk about when we talk about decarbonization? There are two key messages that I want you to take with you. Decarbonization is not just an environmental imperative, it's a business opportunity. And what do I mean by that? I talked about new technologies being implementable, but let's think for a minute. Where has technology evolved over the years? What you did 20 years ago, are you doing today? So can you look at your projects and do something just a little bit better? Let me give you an example. Let's talk about idling of equipment at your job sites. I would dare say your equipment's probably idling more than 20 to 30% of the time. That affects your utilization rate. It probably increases maintenance cost, loss of productivity. But one more important thing, fuel equals money, okay? So by investing in decarbonization, you also have a business opportunity to reduce your costs. Let me leave you with that first point. Second point, decarbonization, like safety, is a journey. You've seen the graphs several times this morning. We're not going to get from 100 to 0 overnight, but it's those small incremental steps that you take that will get you from point A to point B. So as you listen to this presentation, please think about that and think about what this team has to offer to help you in your journey. But we're not going to leave you hanging. Research Team 411 has worked really, really hard over the last 2 years, and we've developed a toolkit to help you wherever you are in your journey. Whether you're starting or continuing your journey, you'll be able to utilize the work that the research team has done to aid in your process. But why do we need to decarbonize? Trends in decarbonization in 2025 have gone to electrification of fleets and equipment. There has been a shift in fossil fuel to renewable power that we've seen. We've seen consumers and end users being more interested in sustainable products. We've seen the emergence of carbon removal technologies, and we've seen also the voluntary carbon market emerging throughout the world. In addition to that, what you might have noticed is that over the last 20 years or so, there has been an emergence in regulations. And they've been divergent throughout the world. Where we haven't seen regulations at the federal level, they've emerged at the state and the local level, and they do impact the way that we do business. I'm just going to leave you with a couple of examples of that. Let's talk about California. Excuse me. California actually has regulation that applies to all businesses doing work in California. So it doesn't matter if you do work in Idaho or Illinois, you're still having to comply. And then you've got the regulations emerging in the EU as an example, CBAM, which puts a carbon tax on products that are imported in the European Union. So it's really important for us to also pay attention to the regulatory landscape. But now that I've talked a little bit about the why, let me pass it over to Jim, who's going to cover the State of the Union. Thanks, Jim.
Thank you. Based on a survey that the research team conducted last year, 77% of the surveyed companies had decarbonization goals. Many of those companies were CII members, some likely in this room here today. And the results of that survey line up closely with another that showed 70% of the Fortune Global 500 had made public climate commitments. And yet, when we asked our survey respondents, 44% did not know how to calculate embodied carbon. This poses a problem because the number of net zero commitments continues to grow year after year. Currently, 45% of the world's largest companies are committing to be net zero by 2050. But regardless of those good intentions, those commitments, Accenture is showing that only 16% of those companies are on track to reach net zero by 2050. That gap from where we want to be to where we are now, that reminds me of our New Year's resolutions, right? At the beginning of the year, we always start with optimistic goals in mind, right? This year, I'm going to eat healthier. This year, I'm going to exercise more. I'm going to save money, right? We always start with good intentions in mind. Now, I'm asking you to apply those good intentions around decarbonization into action. And to help with that effort, the research team has released the following report. All right, let's talk about what the report includes in it, okay? It contains some basic information and a glossary of terms around decarbonization. Then, the research team performed a survey to understand the current landscape around decarbonization. Then, we took all our research and we developed this Excel-based toolkit that contains the content of all that research. And then we applied that research to 2 different case studies in the industrial sector. Let's talk about what's in that Excel-based toolkit, right? Okay, so it takes the standard project lifecycle that I'm hoping everyone here is familiar with, and it lays on top of it the framework for decisions that need to be made around decarbonization at each phase of the project lifecycle. It contains an industry resource guide around different standards and databases for carbon measurement and tracking. It provides a low carbon materials guide for concrete, steel, glass, pipe, and asphalt. It takes the current CII best practices and applies those best practices as they relate to decarbonization. And then it lists methods for reducing carbon in logistics and construction execution. Overall, we hope that this can act as a general education and actionable strategies that you can apply on your projects. What are the 3 things here that I hope that you'll take home with you today, right? Let's talk about 1, right? That the current framework that we're proposing lays on top of the existing project lifecycle, all right? 2, we're proposing that carbon be added as a criteria when you evaluate your projects, right? Most of the projects now are looking at cost, schedule, safety, quality. We're proposing that carbon be added as a 5th metric when you evaluate your projects. And 3, we've started to identify some cost-effective solutions so you can begin to decarbonize your projects. With that, I'm going to hand it over to Hassan, who can provide a refresher on embodied carbon and talk about the scope of our research.
Thank you, Jim. So to fully understand the carbon footprint of a facility, and by facility I mean building, process plant, infrastructure, or industrial project, we need to understand 2 core concepts, embodied carbon and operational carbon. So walk through this slide from left to right. So embodied carbon refers to the carbon emissions associated with the materials and construction activities. Two things, materials and construction activities during the project life cycle. So starting with the raw material, extraction of material, manufacturing process, this embodied carbon, transportation to the job site, and construction activities. Collectively, we call this as upfront embodied carbon, which is very important. This is the highest impact of the embodied carbon emissions. And then taking this to the use stage, where we have replacement, maintenance, repair, refurbishments, all of this embodied carbon added during the project life cycle. And then moving towards to the end of life, embodied carbon emissions, we have the demolition, waste disposal, processing, and disposal. And then we can add the beyond life cycle embodied carbon emissions. Some projects promote circular economy, considering reuse, recovery, and recycling. All of these are embodied carbons. So it relates to the materials, carbon footprint that we select. That's why we need to focus about selecting our materials. We need to pick materials with the lowest embodied carbon emissions. And then the construction processes play a factor into the embodied carbon calculations. Now let's have a look at the operational carbon, because both the embodied carbon and operational carbon together, they define the total life cycle carbon emissions in the project life cycle. So operational carbon, it relates, during the use stage, we have embodied carbon, as I mentioned, but we have also operational carbon added to it. It's about the energy footprint of the energy used to keep the building running, our facilities running. It's related to the energy needed for lighting, heating, cooling, running equipments, using appliances, powering the building. So all the energy it takes to keep the facility functioning every day. This is operational carbon. But as you can see, there's the significance of the embodied carbon across the project life cycle. The operational carbon is limited to the use stage only. RT-411, we've decided to focus on the embodied carbon, upfront embodied carbon. And this is for a reason, because approximately 90% of the total life cycle embodied carbon emissions occur at this phase. And embodied carbon is challenging because once it's released in the atmosphere, it's immediate and irreversible. It cannot be reduced over time, unlike operational carbon, where we can reduce it over time through building retrofits, connecting to clean grid, decarbonizing the national grid, using retrofits, using renewables. There are multiple ways to reduce the operational carbon over the life cycle of the project. Unlike embodied carbon, it's locked from day one. That's why it's very critical. All the decisions that we take at the upfront of the project phase, we are tied into our construction projects. These emissions will shape up our carbon footprint in the future. That's why it's a very important topic, and RT-411 decided to focus on embodied carbon and not operational carbon. Same slide, but just adding the life cycle assessment methodology. Many of you might be familiar with the life cycle assessment methodology, LCA. In the context of carbon emissions, we're adding just titles and numbers to it, and boundaries, system boundaries. So as you can see, going from left to right, we have stages A1 till A3, which is the product stage, where almost 90% of the embodied carbon emissions occur. It's very important. It's a highly impact area. That's why we focused on it. And adding, this marks the cradle to gate. We call it cradle to gate boundary, stages A1 till A3. Extending the cradle to gate boundary by adding the transportation to the construction site and the construction activities on site, we call it cradle to end of construction. And this is marks the end of the RT-411 scope of work. And then adding the use stage and the end of life combined together, the use, maintenance, repair, replacement, refurbishment. And as you can notice here, we have the B6, B7. These are operational carbon. So out of the stages A1 till D, only B6 and B7 are operational carbon. The rest are embodied carbon. And this shows the significance and the importance of the embodied carbon. And adding the beyond stage, cradle to cradle, which is adding the beyond life cycle emissions embodied carbon as well. So now let's have a look at why embodied carbon is gaining significant importance over the coming years and decades to come. Looking at the global building sector emissions is responsible for 39% of global emissions annually. And this is divided into 28% coming from operational carbon and 11% coming from embodied carbon. But this is changing and changing fast. for various reasons. And as of 2021, 75% are operational carbon, 25% are embodied carbon. But according to the Carbon Leadership Forum and various studies, it shows that in the coming decades, the split will have even split, 51 operational carbon and 49% embodied carbon. That's why we focused on embodied carbon. And as I said earlier, operational carbon can be reduced over time. Unlike embodied carbon, it's locked once it's released in the atmosphere, it's permanent, we can do nothing about it. That's why we need to focus and may be mindful of the decisions that we made at this critical stage. Any commitment to the supply chain, collaboration, the material selection, these choices will impact our carbon footprint in the coming years to come. So now we're comparing the building sector with the industrial sector. Building sector have been advanced in adopting decarbonization for various reasons. It's a global source of embodied carbon for embodied carbon and operational carbon emissions annually. And unlike the industrial sector, they have a different set of challenges. They have good reasons. They are still questioning the value proposition of decarbonization, which is very valid, positive ROI from the investment in decarbonization. Similarly, the building sector have been through this 20, 30 years back. And this is where the industrial sector is at this point today. So the progress is slow, but it's eventually coming in the near future. But luckily, we can leverage what we have learned from the building sector and adopt and scale at the industrial space. We can learn a lot from the building sector. Cross collaboration can help us accelerate decarbonizing the industrial space. Let's walk through three major opportunities. One, the building sector excelled in the material substitution and optimization. We have witnessed a shift towards low carbon concrete, low embodied carbon materials, recycled steel, alternative materials. Industrial sector can copy that and use these technologies and innovations in material substitution optimization. The second topic is performance standards and labeling. The building sectors uses certifications such as LEED, BREEAM, Passive House to push the market towards higher standards. And the industrial sector can do the same. We have a lot of frameworks that Ed will be walking you through the toolkit. It's based on the frameworks and standards and methodologies from the building sector. Last but not least is the digital tools and data platform. We have many platforms and digital tools available in the building sector that could be adopted with minimal changes, could be used in the industrial space. In the middle here, I'm showing two images from digital tools used for buildings, from the building sector. The image in the middle below, it's showing life cycle assessment data platform integrated with 3D BIM model and showing interactive embodied carbon heat map. So it can visually, the engineers and designers can locate the high carbon intensity areas and focus their efforts to reduce the embodied carbon impact. The image above, sorry, it's too small. It helps the digital tools enable taking informed decision during the early design stages of the project. You can set the project goals, sometimes competing project goals together, cost against embodied carbon, operational carbon, and the tools can enable us to take informed decisions at this critical stage. Some of these tools are AI enabled. They can provide insights. They can help the engineers and designers to co-generate multiple options, so optioneering, generating the machine and the human can co-generate options, see in real time the impact of cost and embodied carbon on the project. And in fact, the case study that we have conducted during the RT-411 used one of the building sector digital tools. And with that, I'll turn it over to Cheryl to walk you through the case study.
Thank you, Hassan.
Thanks, Cheryl.
So like most research teams, we utilized a couple case studies to check our work. And I'm going to tell you about the industrial petrochemical project, C3 splitter, that we used. There was another one also. It's in the materials. It was a project at FEP3, detailed scope, and the estimate was about 10%. And we met with the project team, sat down, and went through our questionnaire and drilled down from the corporate level through estimating and procurement and evaluated our questions and applied them to their project. And it was apparent that their corporation already had goals associated with embodied carbon. So they were easily able to answer those questions. And for a lot of companies, it'll be readily available in your annual reporting documents. But after that, they didn't have so much in place. And so we've put together further questions to self-evaluate what your project is doing to reduce embodied carbon and save costs associated with embodied carbon. We're providing you with technology and tools and documentation to help you achieve a streamlined and better focused decision making. So our case study, of course, our project had the basic materials of an industrial petrochemical plant: pipe, steel, concrete. And there wasn't a lot of environmental product declaration data on piping. There was some, but not a lot. And so we focused on the structural steel and the ready-mix concrete for reducing embodied carbon. Structural steel in the building industry, they have a lot of information out there. They have a very high recycled content for your average steel, structural steel. Ready-mix concrete, there's plenty of opportunity to use secondary materials from other processes, like slag and coal ash, for cementitious materials in your concrete mix design, if it's appropriate. So other materials on the project made up about 18%. We found a surprising amount of information and on embodied carbon in the pipe insulation, of all places. So we used 2 life cycle assessment softwares that evaluate embodied carbon. They both come with their own database of base materials. And if you stick with one piece of software and you add in your product-specific environmental product declarations, you're going to get different numbers, different differences, but the ratios, the order of magnitude in the results will be the same. So both of our softwares came up with about the same savings in embodied carbon. 80.5% of the savings was in the materials. The LCA stage of A1 through A3, cradle to gate. And then there was transportation to site, 11% savings, and A5 construction, I'm sorry, not 11.2 savings, just 11.2% of the embodied carbon, and construction was 8.3. Those two combined, transportation and construction, is not an insignificant portion of your embodied carbon. So I'd like to talk to you a little bit about actual construction site activity, because that's what I know best. So when you actually get to the construction sites, evaluate your processes. Well, the first group this morning said you got to plan your processes first before you get to the site. So if you don't have the plan in place before you get there, it's not going to work. So plan what you're going to be doing to reduce your embodied carbon on site. Address equipment idling, have a plan in place. Address downtime. And woe be it from me to tell a crane operator that he can't run the air conditioning while he's waiting idle, but there are other options. He can go into the central cooling location instead of sitting on his piece of equipment. So he can keep cool, and the piece of equipment can be turned off. Optimize your power generation. Your generators that are running around running your tools, do you really need one massive generator for these 3 guys running drills? Maybe not. So, but look closely at it, because that diesel fuel that's burning is money. And if it's not being optimized, then it's not paying for itself. And then last but not least, I'd like to focus on waste that you can see up here. Everything that goes in that bin is lost embodied carbon. If it goes in that bin, it's headed for the landfill, and the landfill's got no use for it. Okay? It's only hurting. Every penny that's in that waste bin is money lost on the project. I've got 2 projects to my belt and to my name that I focused on waste, and we had over 80% recycled materials on the project. So it didn't go to the landfill. Our case study results of the life cycle assessment, focusing on embodied carbon for this research, our materials, we were able to reduce the embodied carbon by 14%, just by selection of different materials. The transportation had a minor correction, but the construction site saved another 3.3%, for an overall embodied carbon reduction of 17%. That's money. Every ounce of weight of materials is money for the project, for your profit.
Yep.
Ed, do you want to tell us more specific about the toolkit?
Sure can. Thank you, Cheryl. And hello, everybody. We are excited to share the toolkit with you, and I hope you will be at the end of this few minutes here. As I do that, let me just remind you of just 3 things to keep in mind as I go through this review. Number 1, as mentioned earlier, you're going to see this framework that we've developed as a team integrated in a familiar work process, and that's represented by the arrow that you see there, and we'll talk more about that. Number 2, success metrics for projects remain the same, right? So this is safety, the quantities, and the quality of your projects, cost, schedule. What we are suggesting is adding another metric, embodied carbon, to be optimized amongst those success metrics. And third, our research has surfaced that you can do both. You can lower embodied carbon and have a cost competitive project. So allow me to go and introduce the tool with you here. So as you see this tool, it was inspired by CII's front-end planning toolkit, and that's how we designed the framework. These actionable buttons that you're looking at right now are the stages: feasibility, concept, detailed scope, and EPC, engineering, procurement, and construction. As you hit these actionable buttons, it will redirect you to guidance and links that allow you to learn more by stage what you should be considering to help build your strategy and execute your strategy. Over to the left on the screen, there's an index that allows you to see all the core 5 tools that are in this our toolkit, and that it has decision making. That module there will show you guidance and what decisions happen by stage. There's also an embodied carbon toolkit, and it allows you to understand what tools are out there and available, and the databases that feed those to have confidence on which one you select to build your strategy. There's the alternative materials section that was mentioned earlier by Jim, along with the work practice, project best practices to use that support embodied carbon reduction. And lastly, the logistics and construction, ideas in that phase to also put in your strategy going forward. We're not going to be able to go through all of those today, but you did see a little bit of a glimpse of the decision-making tool application there in that tool. But I encourage you, please go to the app, download it to learn more. But let's move now to the process itself. How do you think about building your embodied carbon reduction strategy from the beginning through the end? And that starts in the feasibility stage. What our research found is it's important for the companies to get together, the business side and the project teams, and align on the embodied carbon goals that you want. And this is important because it needs to be embedded in your business case and align with your company's policy. So as you do that, you're able to bring those ideas in, and we have the decision tool that allows us certain types of things to consider as you shape that strategy early in the stage. You'll move to the embodied carbon toolkit, and this will allow you to select a tool and begin to look at what does it mean to have an embodied carbon reduction plan. You're looking at alternative materials, different transportation to site, alternate construction methods that you have. So these are things you have to consider up front, and you're starting to get a baseline of what does that look like. And once you have that, you're ready to start to think about how do I optimize, or how will these impact the other success metrics that we have. We found that these tools also have the ability to ingest cost data, so you can bring that in and start to get a sense of alternate strategies that compare to the other success metrics that you have for your projects. But with that, now you're ready to move to the next phase. And this is the concept phase. In the concept phase, you are now defining the scope of your project. You are doing preliminary plot plans, as you know, preliminary designs, procurement plans, constructability plans. This level of information can be also put into the embodied carbon toolkit and start to shape out some of those strategies that you were considering early on. What our research found, though, it is extremely important to bring in your project stakeholder community early on. And what that means is EPCs, working with owners, working with your core subs, some of your key suppliers, engineering firms, all together to generate the kind of opportunities that you can consider to shape strategy. And at this stage also, you're able to now have the owner team narrow down to the lead strategy to then take on to the next stage for more definition. And that takes you to the detailed scope phase. In the detailed scope phase, you're doing what you typically do. You're getting P&IDs. You've done heat material energy balances there. You're sizing equipment. You have quantities, weights. All that information also helps to inform your strategy by putting that into the embodied carbon tool. And now you're talking specific now numbers of alternative materials, different methods that you will actually use for construction. And most important at this phase is to decide what is it that you won't do that won't fit your strategy. There are some other options that are out there that may be a great lower carbon material, but the installation method is extending your schedule. And so you can't meet the objective. So as a team, you need to really think that through and decide what stays in and what comes out. Because at the end of this stage, this information will now inform your contract agreements. And that's where everyone is signing those agreements, and you're being held accountable for how you will install the materials that go in, the measuring types of calculation methods, the frequency, et cetera. But it's important that that commitment is now made at this stage. And once you get to this point, you're ready for execution. And now you are truly in detailed engineering. You're ordering equipment. Materials are coming to site at this point. Early works has started. You're moving through construction. And you are doing that with the materials that you've selected that have lower embodied carbon. And you're implementing in the way you're actually tracking material deliveries to site. And the exact method, you're measuring actual, again, versus plan. And you're starting to capture the variances. And you're capturing those variances in a way that it can inform your final project plan report that, around carbon. And that's really important for lessons learned going forward. So let me close with the following. And first, I hope you're excited about this tool. Again, don't forget to download it from the app because it is available to learn more details about it. But take you back to the 3 points. Again, this is embedded or integrated in a work process framework that you're familiar with, and that's the front-end planning. Number 2, success metrics for projects remain the same. You know, the safety, quality, cost, schedule, and we're suggesting to add embodied carbon as another element to optimize amongst those project success variables. And we want to emphasize once again, we can do both. We can actually lower embodied carbon and have cost competitive projects at the same time. So with that, let me turn it over to my colleague, Jim, to take us home with the call for action. Jim?
Thank you. Third time today we've seen this. It's not even time for lunch. All right, 33 years ago, CII released SD86 with the goal of listing techniques and best practices for achieving safety excellence on our projects, with the goal of eliminating all accidents across our capital projects. It's been quite the journey, and we've made incredible progress. The total recordable incident rate is down 90%, right? We're not at zero yet, but we're getting close. And we feel, as said earlier, that decarbonization is going to mirror that journey with safety. And hang with me here with this analogy, all right? So first, step 1, it's about identifying the opportunity for improvement, all right? So with safety, we recognize that the number of accidents that we were seeing on our problem, or number of accidents we were seeing on our construction sites were a problem. Now, our focus here is on reducing carbon. Step 2, the executive team, right? For safety, back in the 90s, we started to see the rise of vice presidents of safety into the executive ranks. And now, you're starting to see the vice presidents of sustainability rise into those same executive ranks. Step 3, and I think this is where most people are, right? Based off that survey I talked about earlier, 70% of us are here, right? we're setting company-wide goals around decarbonization, around sustainability, right? That's probably where most of us are at. Step 4, right? Now it's time to identify baselines for our projects and start to set project-level goals. Remember previously I talked about New Year's resolutions, talked about weight loss, right? The secret to weight loss, right, is incremental steps, right? 10 pounds here, 10 pounds there, right? You don't immediately aim for losing 50 pounds, right? It's a step-by-step process. And that's what we're suggesting here, right? Can we cut our embodied carbon by 10 or 20% on our projects? I'm not suggesting we start with nothing and go full net zero on our projects. But let's start to take steps now to cut our embodied carbon by 10 or 20%. Step 5. Now we need to identify the strategies that we're going to employ to cut the embodied carbon on our projects. That's where this research comes in, right? That's where this toolkit comes in. We're trying to lay out a path to help you on how you're going to do that and how you're going to get there. Step 6, improve, repeat, and iterate. 6 steps. Seems easy, right? But you've got to keep in mind that the typical project life cycle is 3 to 7 years, right? If we're going to make 2050, if we're going to be net zero by 2050, we don't have a lot of time with a typical life cycle of 3 to 7 years to iterate on our processes and to get our supply chains and vendors on board to meet those decarbonization goals. So, regardless of where you are on this journey, right? Maybe you're just starting out and you need to start looking at company-wide goals. Or maybe now's the time that you need to start looking at project-level goals, right? I would encourage you to set your decarbonization goals for your company or your project, wherever you're at. All right, please download the toolkit. It's in the CII app. It helps lay out a framework for the different decisions you're going to be needing to make at each phase of the capital project. I would encourage you to stay engaged and educate on this. I know that this is a new topic for a lot of people here, and there's a lot here, right? The research report will be available later on this year, and it's a great place to start learning about everything that decarbonization includes. Regardless, please, I encourage you to begin or continue your decarbonization journey. Thank you everyone for attending. This is Research Team 411 with Leading the Charge in Decarbonizing Capital Projects. Are there any questions?
Well done. That's a lot of information. There are a few questions. We have about 5 minutes. So I'm going to try and give you a couple of these. Can you provide an example of when a company can realize both lower embodied carbon and competitive cost? Or have you been able to identify a cost associated with the embodied carbon reduction?
I'll talk towards that. So we have anecdotal evidence from some of our team members who have been able to procure reduced carbon concrete and green steel at competitive cost levels that you would normally go out and get any of those materials out in the market right now today.
Hey, may I add just one other point to that? And I wanted to mention another example of a product called Gator Bar. So this is like a resin that goes on rebar, but it lightens the weight of all the rebar and reduces the time to tie it up, and so it has also demonstrated lower cost to install. I mention that because I forgot to say in the speech, part of it is that not all material is in the tools. but there is enough to get started with your embodied carbon strategy plans. This is one example of that was not in the tool.
Okay. Next question. Can you explain how the design integrated LCA tools work and their compatibility with BIM? BIM?
Sure, I can take that. There are various tools available in the industry. Some of them are working as standalone digital tools. Some of them are integrated with building information modeling. And as we presented today, they can provide interactive embodied carbon heat map, showing where the high carbon intensity areas are, focusing the efforts of the engineers to select other materials and see the impact in real time. So there is lots of technologies. Technology is fast. We have AI-driven technologies. I mentioned generative design. The machine can co-generate options, hundreds and thousands of options with the engineers, something that we couldn't imagine before. So I think technology is inevitable. We had to keep using technology, but I'll stress on the importance of data first, because data is key. You need to have structured data, accessible data, trusted data, so you can build on that and leverage and tap on all the opportunities that AI can provide us in the future. But yes, to answer your question, yes, we have integrated LCA tools to the BIM using the LCA methodology, and it provides success in the building sector, and it's readily available to be transferred to the industrial sector.
Thank you. Next question. What were the changes that resulted in the 17% reduction in emissions in the case study?
That was mostly in the concrete, if I remember correctly, and the pipe insulation was a surprise to us. But yeah, swapping out the cementitious materials for a lower embodied carbon, recycled cementitious materials, resulted in a huge increase because the cement of your concrete mix design has a large part of the embodied carbon.
Okay, we have about 2 more minutes, so I'm going to try and pick one more. See, in the case study, you reported that the savings in embodied carbon, what was the correlated cost savings?
So we avoid looking at cost in the research project, and we avoided that primarily to make the research evergreen.
That's fair. Are manufacturers and vendors that supply low carbon materials readily available, and are they cost competitive?
Maybe I'll make a comment. I think it depends a lot on your project, what you're evaluating, your geography. So there are vendors available, whether or not a specific material makes sense for the project. We're talking about alternative materials. We can talk about alternative fuels too. That's something that we've evaluated for equipment, and that's very geography based, and that's actually a very good alternative to reduce emissions. So on the alternative materials front, what we're doing as an organization is looking at project by project and identifying kind of the different interventions that we can take, and then evaluating it both from a feasibility in terms of availability as well as cost.
I can add to this. There is, by Carbon Leadership Forum, they have developed a tool called EC3 tool. It's available for free. It has a wealth of information about the materials available that you can choose from, with lots of environmental product declarations that you can select materials and see the impact in real time. And it could be integrated with BIM if needed as well. That's available for free.
Awesome. Well, thank you guys. This is a great presentation. There's a lot of questions that have come in that you can look over and provide some response back to. But everybody, thank you for leading the charge in decarbonization of capital projects.